Okay, then now let's discuss about the next practical exercise, multi-criteria evaluation for site suitability. So, sometimes when you are going for the work as an environmental analyst or environmentalist, you, your supervisor or someone over there in the office may ask, okay, we need to identify the suitable site for the evacuation. Just imagine, like for this exercise, what we are going to do. If there's a landslide is going to happen in Sri Lanka due to extreme precipitation event going on, like the central province, we need to evacuate the people into the most suitable sites where we do have like certain amount of things. Like just imagine, like okay, uh, that suitable site should be like closer to the road. It should be like less than 500 meters, and then the other factor is like it should be within 1 kilometer radius of the school, and then within 2 kilometer radius of the hospital. And the other main factor is like it should be less than 15 degrees of slope. Uh, so with these all the factors combining by weighted average factors, we should be able to identify the most suitable location for these people to be evacuated. So now we are going to do like how we can do a simple calculation like this in this kind of emergency situation. For this one, actually, what how many data sets that we need is like here is like for you guys to do a simple practical. For in real world, you need to include like lot of factors. In here we are only discussing about these four criteria. Sometimes in real situations it might be more than four, or it should be closer to like 10 or 15 criteria, and like the weighted factor will be depend on your actual situation. So now for this exercise 2, I give you the link, the same link. You can go into the exercise 2, and then you can download that zip file for the second exercise. So in this zip file you should be able to see how many files you should be able to see, four distinct file. So this landslide hazard or the safety map, it should be the dim file. So I will give you the dim file because we don't have, unfortunately I couldn't find any landslide hazard map for Sri Lanka. We will use the digital elevation map, so it will be in a TIFF file format. And then we do have like health. So health, that means the hospitals. And then the education, the schools, where the schools are located is like I have extracted this one from the OpenStreetMaps. And then we do have the road network. So in this zip file you will see these uh, four different data sets. So now let me wait this till this file being downloaded. Okay, meanwhile the data is being downloaded, I will open my arc map file for the analysis. Download, and then I will open arc map for this analysis. Here also we will use some tools that we have discussed earlier on the first exercise. So actually these are the main tools that you will use in most of the cases. Okay, the file is being downloaded. For this one also I will create a folder under D CME40 prac. I will type EX02. Done. I will wait till ArcMap to load. Okay, I will close this one. file, new, then same thing. Geodatabase, don't use the default geodatabase, create your own geodatabase. So I will select the previous one or this one. This PC, local disk D, then CMBF40, EX02. Okay, I will create a geodatabase. I will give it a name EX02. So this will be my geodatabase file for the exercise 2, and then I will click add. Then I will click on bank map and click OK. Then I will save this one in that same exact directory. So now it should be in ex2, type ex02.mxd and click save. So now I should see these two files in my directory. Now is okay. Now I will go back to my downloaded file. I will open my downloaded file from here. Then from there I will extract these files. I will select these all the files, copy, and then I will paste this one in ex02 size 2 exercise 2. I will paste this all the layers. Okay, now I do have data, my ArcMap file, and then my geodatabase file. Now I will go back to the ArcMap and then refresh here. Then I will see this exercise 02 file. Now I will load all the necessary data files. So my provinces layer is there because I need to extract the Kandy district from there, and then I do have my hospitals layer. So here you cannot see it clearly, but if you zoom, let me open the attribute table and click on one file. You can see the files are, they are all the hospitals in Sri Lanka were listed in this file. So next one is zoom to layer, and then the next one is road networks, drag and drop. In the schools, drag and drop. So I do have all the road network, the schools and hospitals files in here. I think I have forgot to upload the if file in here. Actually, I forgot to upload the diff file in here. Let me download the diff file as well. Same link. Click on refresh. This is the diff file that we need. We'll download the file as well. So this is the actually the digital elevation model, or we called DEM, SRT DEM. Okay, now the file is being downloaded. After downloaded, I will copy this file into my exercise directory, data files, and then I will open that file as well from here. refresh. Digital elevation model is asking to build the cubic convolution. I will say LC77 and then click yes. Okay, I do have the digital elevation model, provinces, schools, and road networks. So first thing, we need to clip the data, because right now we are not going to do this exercise for the entire Sri Lanka. We are going to do this one only for the Kandy or the central province. So for the, if you are going for the central province, what we need to do, you guys should know right now. You guys should know what is the basic first step. First step will be, we need to uh, convert the projection system, but here I am going to do the other way. First I need to clip all the data layers into one specific I need to clip all the layers into the central province. So I will clip all the necessary layer files into the central province. So first I need to extract the central province from the provinces layer. For that I will right click on right click on provinces layer and open the attribute table, and then select the central province, and then I will do the clipping. So go to the search, click on clip, do search, then under analyze, clip, and then select provinces. Then the clip feature is also provinces, and then this one will be central province. Then I click OK. So now I should end up with the central province shapefile. And now if I remove this provinces file, I should end up with the central province shapefile. So you can see the central province shapefile from here. Now I need to clip the road network, and then the schools, and then the hospitals, and as well as the DEP. So I will do the same step for all the the rest of the files. For the road network also I will do the clipping, and then clip feature is central province, road network, CP. I will type road network underscore CP. Okay, now I will remove the full road network file. I don't need the full road network file. I will do the same thing. For the schools in CP, select the clipping feature central province. The schools in CP be my output layer. Click OK. Okay, now the schools have been selected, so I will remove the total schools layer from here, and then click on the analysis, select hospitals, and then central province, hospitals in CP. Click OK. I remove the rest of the hospitals from there. So I ended up with all these files. Now I need to do the same thing for the table. For the DEM, when we are doing the clipping, we have to search for clip raster. This is the tool that we have to find when we are clipping the rasters. So clip in data management, we can use this tool when we are clipping the rasters. Okay, for this one also input raster will be my DEM file, output extent will be central province, and then I have to put the tick mark, use input features for clipping geometry and maintain clipping extent option. Then I can click OK. Now if I remove this one, forget to give it a name. Let me give it a name. Central province. Clipping extent is central province, and then use input area, maintain the clipping extent. So output will be DEM for central province. I will click OK. Now you can see even the digital elevation model file is also being perfectly flipped into the central province file. So I will remove these files now. So I have the clipped files. Now the next stage is we need to convert these all the layers into which format. We are going to do some calculations. So we are going to do, if we are going to do some calculations, actually what we have to do is we need to convert all of these files into the projected coordinate system, because right now every single file is in geographic coordinate system. If you open this DEM file as well, all the single files are in geographic coordinate system. So we need to convert these coordinate systems into what we call Khandawala coordinate system. So first, for the layers, I will set the coordinate system Khandawala. So here I can search Khandawala. Under the projected coordinate system, national grid, Asia, Khandawala, Sri Lanka grid. Apply. Yes. Okay. Now I need to convert each and every single layer. I have to do the projection. I will do the reprojection. So project. Data set will be for network CP. This one will be like CP projected. So I will say CP projected. The output coordinate system will be search for Khandawala. Click OK. Projection for the rest of the files as well. Hospitals, CP projected. Output coordinate system will be Khandawala grid. Then I will do the projection for schools as well. Do the projection for the central points. Boundary file or center points. Boundary file. To remove this center province file, finally I will do the projection. For the dam file, this one into on the properties. On the Okay, actually for the dim you don't need to do the projection part. Do the project. You don't need to do the projection for this what we call the dim file. I will revert the projection the coordinates to zone 44 and raster file. Okay. I think I have damaged the projection system of the DEM, so I will do the clipping again. So how we can do the clip? Go to the catalog, refresh, and then the geo database. I will refresh the geo database. I will all these files. I will delete this DEM file. I'm going to reclip it again. Delete this. Okay, I will load the initial DEM file again, and then central province shape file. Then I will do the clipping part. Master, data management, and then DEM geotiff, and then central province. Use maintain clipping extend. Central province. These kinds of mistakes will be happen from your side as well. So whenever a mistake happen, don't panic. Just repeat it. Just delete what you have done, undo it, and then repeat it again. Okay. Now I will do the calculation. Okay. Now we have done everything correctly. So we do have the raster file, and then I will remove this central province file from here. So we do have all the layers. Now we have prepared our data. So we need one thing to do now, prepare in the binary factor maps. So what we need to do the binary factor maps mean, we have the digital elevation model. From the digital elevation model, we have to convert it into a slope. So how we can do the conversion of the DEM into a slope is, in ArcMap we do have a tool called slope. So if we see this spatial, under the spatial analysis we have a tool called slope. Click on the slope tool. Click on the slope tool and input raster the central province DEM, and then this one will be the output raster will be slope for central province. I will type CP, and then decrease, and then planners effect optional. I will type 1 and then click OK. Now it have calculated the slope, that means the angle of that specific terrain. So if the terrain angle is less than 15, we can consider as it is as a flat terrain. If the angle is higher, that means we do have hilly regions. So in here you can see in the red color we do have the hill regions. Now I will remove the DEM file from here. We need the slope file, and then from slope file we need to do the reclassification. So we have to say reclassify under this partial tool. So we have to select the input raster our slope of the central province, and then we have to select the values, and then we have to do the reclassification. So if it is under less than or less than 15, then it should be, we can like categorize it as like perfect area. So new value will be 1. I will say 15, 0 to 15 it should be 1, and then from fifteen to 20, I will say 0. So if 15 to 0, it should be 0. Delete this one, delete entry. 0 to 15, 1 at the entry. 15 to 90, it's 0. Then change missing here is no data. The classes 2. Okay, and then from here we say 15. From 15 to 79. Click OK. So I do have 1 and 2. 1 mean the terrain is less than 15 meters, 15 degrees. The angle is less than 15 degrees. No, the slope is less than 15 degrees, and areas which were highlighted in 2, this green color is the areas we have the mountain region. Okay, now we do have these areas as well, the regions as well. Now what we need to do is we need to convert this one, because right now we do have a raster. We have to convert the raster into a polygon. So how we can do the conversion from raster to the polygon? So we have a tool called raster to polygon. So we have to use the raster to polygon tool. So from raster to polygon tool, we can input the reclassified raster, and then we can put the value, and then we can say raster. This one is the slope. Polygon, and then simplify polygon optional, and then click OK. So now if I click on the attribute table, I should be able to see multiple polygons with the grid code 1 and 2. Grid code 1 mean where the slope is okay, that means slope is 1, and rest of the files are like the angle is higher than 15 degrees. So I will remove the reclass as well. Now we do have the layers that we need to go ahead. Now we need to do some attribute modification for all the road networks. First we need to do the buffering. Actually first we need to do the buffering, because here we mention the road should be from 15 meters. So I will do the buffering for the roads first. So road network, I need to do the buffering. I will say buffer. Then from the analyze tool, I will select buffer. Then select road network CP projected, and this one should be road network CP. Then 500 meter buffer. So linear unit should be 500 meters, and then dissolve. We say all, and then click OK. So now finally I should be ended up with the road with 500-meter buffer. And then the next criteria is education. So from schools it should be 1 kilometers, and from health centers it should be 2 kilometers. So now we are finding the perfect spot for the rescue camps, or if we are in a position we can announce like a disaster management center. If you are working in a disaster management center, you can do a simple analysis like this and like announce the people to move into these specific regions when an emergency situation happen. So let me wait till this one finish. Some time, especially for these road networks, it takes big time for the buffering. Okay, now roads have been buffered, so I will remove the road network from here with the buffered layer. And then for the education, I need to do the buffering. That means for the schools, I need to have a buffer in kilometers. It should be 1 kilometer for schools, 1 kilometer for schools, and 2 kilometers for the hospital. So I will say CP K of, and then this one should be all. This all should be all, and click OK. Okay, now the buffer zones has been created for the schools with 1 kilometer radius. Now we'll do the buffering for the hospital. For the hospitals also we need to do the buffering. It should be in kilometers, 2 kilometers away. And this one should be dissolved, should be like all, and then click OK. Okay, now we do have the buffers for schools, hospitals, road networks. So I will remove the school CP and the hospital CP from the project. So the next one is we need to have okay, now the buffering is finished. After the buffering, what we need to do is we need to do some weighted calculation. Before the weighted calculation, actually we need to modify our attribute table. So is for our own ease. Just imagine we will assign for the hospitals, we will open the attribute table and then create a new field. We'll go to the add field. And then we will make a short integer field named is score underscore. This one is for hospitals, is called hospital, and we can put short because we are going to specify 1 and zeros for this one. Then click OK, and then put the value. We can do the calculation, calculate no, geometry, calculate field calculator, yes. Now score equal 1. Okay, then for the school also we have to do the same thing. Open the attribute table, create new field. For this one we can type score school short integer. Okay, then right click, calculate field, school is equal 1. Okay, and then for the road network also we have to do the same thing. So I will create a new field, go underscore road. Okay, calculate field, yes, 1. Okay, and for the slope also we will open the attribute table, and then we will create new field, go underscore slope. Okay, now we have to do the selection. We have to select where grid code equal 1. As you remember, grid code 1 mean the areas where values are slope values are less than 15. That means the terrain is flat, so is okay for uh, evacuation, to build the evacuation center or announce the people to evacuate to those regions. So actually these regions are the uh, flat terrains. Now I will click close, and then I will do the field calculator. I will type score slope 1 and click OK. You can see all the places where grid code is equal 1 has been converted into the score slope into 1. Why I have done this one is because we need to do the simple calculation like this. Score is equal like scores of road times then 0.2. So if you are considering the road, it should be like multiplied by 0.2, and then if it is considering with the education zones, it should be like 0.5. Then we will have percentage values from 0 to 100. So that means if we have 100% value, that means is more suitable place, like between 80% to 100%, we can say okay, this place is more suitable for this one. Actually this is the weighted value that we are going to give for each factors. Now after we doing this one, we need to combine these all the layers into one single file. So I discuss how we can do this one. We have to use the union uh, tool. We have to go into the union tool and click on union analyze, and then we have to add all of these layers. First I will add the slope layer, then I will add the road network buffer, and then I will add the school buffer, and then I will add the hospital buffer. Now we need to add these all the fields, and then from here I can type central province underscore union and click OK. Now what should it do is like it should combine all of these files into a one single file where we can do the calculation, because now we need to do a calculation to obtain the results. Okay, now the union command is done. If I open the attribute table of the central province union, you will see something like this, where we can see all the score. We have scores for slope 1 1 1 1 and zeros, and then we have school scores for schools, ones and zeros, and then score for hospitals, and then we have score for roads. Now we need to do the calculation. To do the calculation, what we can do is we can create a field. I will create a field for this one. Add the field. Let me remove this all the unnecessary layers from here, and with this central province union. And now I will create a field name final score. So you can type weighted average. For this one, I will use the double. Click OK. Now here I have to do the field calculator. and now I have to do the calculation part. So the final score will be this one, the score of the road times the weighted factor, that means 0.2. And for to bypass the null values, because if I go over here and like you will see there are like zero values, so we have to type something like this. In bracket we have to type okay, score of the slope, and then I can say O 0, then multiply by the value of the slope that I gave. The weight of the slope is 0.4, 0.4, close the bracket, and then plus score of the school, put two brackets, and then you can say O 0 multiply by school of the school is education is 0.25, close the bracket, plus two brackets of hospital for 0, close the bracket, multiply by the school of score of hospital is 0.15, plus two brackets, score of the road for 0, close the bracket, multiply by 0.2. Now I can click OK. So actually here field calculator, OK, then click on Python. So just copy and paste this command on the Python. Select the Python instead of VB script and click. So slow. Okay, now you can see the field value has been calculated. So if I sort the final score values from here, if I filter the final score values, you can see some places I have the 1. So if I select one place like this and zoom into very specific area, they should have met all these criteria. That means you can see this score. That means the slope is less than 15 meters, and then it should be within the school, and like is within the radius of the school, 1 kilometer radius, and the hospital it should be within 2 kilometer radius, and even is like within the radius of the road. So these are the high suitability areas. Now is up to you. So if I zoom out the layer, now we can visualize this one in a proper way. How we can visualize? I can like right click and then go to the properties, and then I can go into the symbology. Instead of single symbol, I can go to the categories, uh, quantities. I can go to the quantities from the symbol, go to the symbol, layer properties, symbol, then quantities, then graduated colors. For the value, you can see the final slope, and then don't need to normalize. You can have three classes. Say okay, if it's like that, I can like do the percentage. I will do the percentage calculation. Let me do the percentage calculation. I will click over there and then add another field, name percentage, then dot integer. Okay, we'll do the calculation for this one, field calculator, and then I will say final score. This one, final score times. So now I can go here, central province union properties, and then under the quantities you can say the percentage, clauses by the range. So I can say 80. So I can invert the color ramp from here. I will select color ramp. So now you have the map. We do have the suitability. So for this one, I can do the labeling. I forget to do the labeling. I will go back to the properties and say this one is very suitable. Is suitable. And then this one is moderate. Okay. Suitable. Suitable. Then click apply and click OK. And now we can create the map. So we can click on this layout window. Then we can click on the properties. And then we can set the size. Now go to the properties. We can print setup. Then select on the page size. This is like creating your map. I will select A4 and then should be landscape. Okay. Then data frame. Right click this layer. As I can add properties. I can add coordinate for the grid. I can add grid, new grids. Labels, labels only. divisions. I can select from here and click finish, click apply. Then likewise we can add the what we call the grid, and then we can go into the properties. Go to the insert, and then we can add north arrow. Select a simple north arrow like this. That scale bar. Properties and set the scale unit. You can convert the units into the kilometers or something according to your preference. Okay. Then insert legend as well. So now I can properties. I don't need to show the items. Stylize and describe and this one. Apply. Grid. I can go to the grid file. Because I can set to 12 or something like that. So like this you can modify your final map for a good quality presentationable image. So you can use this one in your presentations or some other materials, like even in reports. Even if you write a report or something, you can use these kind of. So this one is totally up to your creativity. With the time, you can create something like that, a title as well. Like this, you can customize your map according to uh, your need, and then you can even output this map by right clicking and then page and print. Map, load the file and then export map. Then you can select the folder, JPG, and click save. You can set the resolution that you need, how many dpi and the pixel, and then the format. Then you can click save. Now you can see it started exporting the map. Take a while to export the map. So after it have been exported, you should be able to see your image file in here. now you can go back to your directory and see your exported map. You can zoom in and see which areas are more suitable and which areas are not suitable. So that's how you can do simple site suitability analysis map creation. So here the map is not 100% perfect, but you can do the modification, like you can like play around and modify the grid to be in equal distances, and then you can turn off these grid lines, and then you can like make it dash pattern or something like that. You can do whatever the thing as per your creativity. So that's the second exercise. In next exercise we will discuss on uh, partial join and how we can display socio-economic data. For this one, what we will do is like we will get some census data on the Jaffna, and then we will do a simple analysis according to the density, where we need to, okay, this population density is this much and we need to accommodate like some hospitals. So which grammar necessary divisions actually we need to focus on, like creating these new hospitals or providing the sanitary facilities. So in the next exercise we will discuss about that.